Hello everyone. In this video, we'll try to understand what is multicollinearity, its effects over a regression model, and how to identify it. So now let's try to understand what is multicollinearity. So when we have a high correlation between two or more, in fact, more than two variables, we can say multicollinearity, right? Just for more understanding, right? So what is correlation, right? So correlation says what is the effect of changing a value in one variable will affect the value on another variable, right? So when you talk about multicollinearity, it says what will be the effect of the change in a value in a variable will affect the values that is more than one or two variables, right? In simple, correlation is one to one, where when when you talk about multicollinearity, it says one to many, right? So both multicollinearity and correlation will create a redundant information that may lead to skew our regression models, which means obviously, right, if two columns are carrying the same information or more than two columns are carrying the same information, right, then obviously we are carrying the duplicate information, right? That may skew our model. Right? See, either multicollinearity or correlation will never affect our model accuracy. The R square will be always good. But only problem, one of the major problem, right? So when you talk about multicollinearity, we cannot interpret the significance of a p-value. We already seen in our previous video the importance of the p-value, right? The p-value will tell you how significant your variable is for a given regression model, right? So now we already discussed, right? If the value of p is greater than 0.05, then that particular variable is not significant. When we can say that? When I don't have multicollinearity in my dataset. If I have a multicollinearity in my dataset, then I cannot interpret my p-value. So I cannot simply believe on my p-value when we have a multicollinearity. So one of the technique to find the multicollinearity is VIF, which is variance inflation factor, right? So if you see the formula of VIF, right, it's 1 by 1 minus R square. We already know what is R square, right? So R square is like one of the accuracy metrics for our regression model, right? Now we'll try to understand how this VIF works. So we'll take our Boston house data, right? So that we used in our all previous videos. So if you observe, right, so we don't have a dependent variable here, right, which is our target variable, because we obviously need to find the multicollinearity between our independent variables. I'm not worried about the dependent variables, right? Now we'll try to understand, right? So now in this independent variables, first I'll make this CRM as my dependent variable, which is my target, and I'll make remaining variable as an independent variables. Now I build a regression model, right? So I'm repeating myself again. I'll make CRM crime as my dependent variable, which is my target, and the remaining variables as an independent variables, and I build a regression model. Now I'll find an R square. So what are the R square which I get when I make my CRM as an dependent variable? That I'll substitute in this formula, which is 1 by 1 minus R square. Similarly, I'll make Zn as my independent variable, Indus as my independent variable. So I'll make each and every column, my variable, I'll make it as an dependent variable, and I build a model, and then I'll find an R square. I'll substitute it in this formula, which is 1 by 1 minus R square, and then I'll find an VIF. So we'll jump into Python code, and we'll see how to find this VIF. So yeah, we again use our stats model, sorry, from stats models dot stats outliers, yes, outlier influence input variance inflammation factor. Great. So now obviously I don't need my label, right, which is my dependent. which is my target variable, right? So drop label x is equal to 1. Yeah, in my x variable. So now I don't have my target. Great. So let me create an empty data frame. VIF equal to ed.data frame. So now in my empty data frame, I am creating a column called VIF is equal to I am using list comprehensives here. So this is my method which I just imported, and so x is the my data frame which has all the columns other than the label, right? So I'll say x dot values, right, comma I. We'll try to understand. For I in range of my x dot shape of 1. Okay, so we'll try to understand this now. So when you say x dot values, yeah, it's a list of list, right? So what are the data frame you are seeing here? So we are getting the same, right? So let's say if I say 0 here, did you see this? So this values belongs to CRIM, right? When I say 1, this value belongs to ZM, right? So I is nothing but the index, right? So if you see the shape, it is 13, which means, let me show you, right? So I have 506 rows and 13 columns. So I'm just iterating on each and every column. Clear? Let me run this. Now, if I say VIF, yes, here we got it, right? So I'll tell you. So I have a value called 2, 2.8, 14, 73, 77, right? So which value I should consider? So there is no such thumb rule, but the practice which we follow in most of the cases is, if VIF value is greater than 5, then we'll consider this variable is creating a multicollinearity problem. So some people will say if the value is greater than 2, also they'll consider there is a multicollinearity. Okay, it is little bit confusing, so let me add one more column called my x dot COLUMNS. Spelling mistake. So now let me run this VIF. See, so now this CRIM, the VIF value is 2.1. So in our case, let's say if we take the value which is less than 5, the VIF value is less than 5, then I can consider this CRM as a good. It is not create any multicollinearity problem. We'll just try to filter it out. VIF, comma, VIF is maybe less than or equal to 5, right? So we have only 3 columns where the value of VIF is less than or equal to 5. So it says if I use these 3 columns, then I don't get any multicollinearity problem, so that I can interpret my p-value. But do you really think, right? So we have this many columns, almost 13 columns, and it says like these 3 variables are is not creating any multicollinearity problem, so just delete all the remaining 10 columns and use these 3 columns as my independent columns. I don't think that make any sense, right? So obviously, right, in this case, so I would prefer to go for non-linear models like polynomial regression, tree-based algorithms, whatnot, right? So hope you guys enjoyed this video, right? So next video will be quite interesting. So we'll talk about the REST APIs, right, web services, and also we'll see how to deploy our the linear regression model. So that will be really quite interesting. So hope you enjoyed this video. Stay tuned. Bye bye.